Instruction cycle. What instruction cycle is? Whenever computer is performing any operation, so a series or a sequence of steps or actions are carried out. These sequence of action performed by the processor to execute each instruction. So whenever the sequence of steps are performed by the processor, so those steps are known as an instruction cycle. The execution of instruction is basically divided into 3 steps. Whenever an instruction is executed, so basically a 3-step procedure is performed. What are those 3 steps? The data retrieved from main memory, then it will check it out that which action is required to perform that, and the last one is carried out that action or the execution is performed. So these steps are called fetch, decode and execute, or this instruction cycle is known as fetch, decode and execute cycle. So let's start with the fetch operation. What fetch is? The control unit fetches the instruction from the memory where these instructions are coming. These instructions are coming from the main memory. Then this instruction is transferred from main memory inside the register. So whenever data is taken from main memory, it has to be transferred to the instruction register. The fetch operation places the instruction into IR, which is known as the instruction register, which is inside the microprocessor. So data which is there in a RAM, it will be taken or fetched from your main memory and put inside the registers. And which register? Instruction register of your processor. So data is right now inside the register, and who is doing that? Basically control unit is responsible for that. The next step is decode operation. Whenever these instructions are coming inside the register, the next phase is to examine the nature of the instruction, that what operation are required or what these instruction means. So the control unit translate these instruction. The instruction which has been fetched, which is inside the register, so the control unit then translate that instruction. This process examines the nature of instruction to determine further operation, that what type of instruction is this and how it will be operating. It also gets any operand if required by the instruction. So if any operand is required which is available inside the main memory, so that operand is also fetched out. So you get to know that what are the requirement for executing that instruction. So decode is to understand that instruction which is inside the register for a ALU. The third one, operation in our instruction cycle is our execute operation. So whenever the decode is done by the control unit, then the control is transferred to the ALU, or the instruction which is being decoded, those instructions are sent to the ALU. After decoding the instructions and getting the required data, maybe some data is required, some operands are required, so those data and the instructions will finally execute by the CPU. And who is going to execute that? ALU is going to execute that. The instruction may perform different types of operation, such as arithmetic and logical operation. So ALU will exactly perform that operation. Then again, next instruction is fetch out from the main memory, put inside the register of the processor, and then control unit decode that, understand that what is inside it or what that mean. Then the data as well as the instructions are transferred to the control unit, to the ALU, arithmetical logical unit, and the output is then furthermore fetch out, then again next instruction. So it is continuous running of a cycle. Every time the data is taken, decoded, executed, data is fetched, decoded, executed, data is fetched, decoded and executed. CPU architecture. There are two types of CPU architectures which are follows: CISC architecture. What are CISC architecture? CISC stands for Complex Instruction Set Computing. It is the traditional types of CPU architecture that supports large number of instructions. It executes complex instruction more quickly, or it use more complex circuit to decode the instruction. It required multiple clock cycle to execute an instruction. CIC is a complex instruction architecture due to the instruction used at hardware level. Intel 486, 386 and Pentium series use a CISC processor. So it's a complex instruction set computing, and in an old CPU this CISC architecture were utilizing. Right now latest architecture is a RISC. What RISC is? RISC stands for Reduced Instruction Set Computing. As its name shows, that reduced instruction. CIC, complex instruction set computing. It only contains the most frequently used instruction. So inside it, what is there? Most frequently used instruction will be there. It executes simple instruction more quickly than a CISC CPU. So we get to know that the instructions will be executed more quickly as compared to the CISC. It completes most of the instruction in one machine cycle. But if you remember that in a CIC architecture, 2 cycles are required for executing an instruction. So here it requires multiple clock cycle to execute an instruction in a CISC. But while we talk about a RISC, here it required only one cycle to execute an instruction. It allows the processor to handle several instructions at the same time. So the good thing is that in this RISC architecture, that multiple instructions can be executed at the same time, but CISC will execute one instruction at a time. Whenever we got multiple cores inside our processor, so CISC architecture is following, because those processors execute several instructions at the same time. CISC architecture use less power. If you see our latest computer or latest processor, so their power consumption is less. It can be developed in less time because its design is simple as compared to the CISC processor. Some example of a RISC processor are IBM Power PC, SunSpark, and tablet PCs. So the tablet PCs or the latest PCs use a RISC architecture. That is the architecture of what? Architecture of your CPU or microprocessor. So let's discuss differences between complex instruction set computer and reduced instruction set computer architecture. So there are some following differences. CISC architecture utilizes more cycle than RISC. If you remember, we have discussed that RISC processor utilize one cycle to execute an instruction, but CISC architecture utilize more instructions to execute an instruction. CISC has many or more complex instructions than a RISC. So we get to know that CISC is a complex instruction format, while RISC is a simplified or easiest instruction format. CISC typically have fewer instructions than a RISC. CISC implementation trend to the slower than RISC implementation. While we are using complex instruction format, so automatically your processing speed will be slower. While we talk about RISC, so its implementation is faster as compared to the CISC. Computers typically use CISC, while tablet, smartphone, and some other handheld device, they use RISC. So let's discuss about Intel and AMD processor. I think so most of you use a computer, and inside the processor which you have, that is a Intel processor. But in the market we got two types of processor. One is Intel and the another one is AMD. AMD stand for Advanced Micro Device. Both of these companies manufacture processor for different devices, such as for desktop computer, for laptops, for notebooks, and for mobile devices. Different processor perform different tasks and have different speed. So we got different types of processors are there, and depending on those types, their speed is also different. Let's discuss about the Intel, the world's largest manufacturer and supplier of a microprocessor to the most of the computer is a Intel. Do you know that Apple computers also utilize Intel processor? So means that they are also taking the processor from a Intel company. Some popular processor of Intel include Core, Pentium, Celeron, Axion, and Itanium families. So right now, which one we are utilizing for a desktop computer? That is a Core processor, because you are using Core i3, Core i5, and Core i7, and the latest one is Core i9 processor. Pentium was the old one, Celeron was the old one, Axion is used for a server motherboard, and some other families are there. Some common processor by AMD are Athlon, Phenomenon, Sempron. So these are AMD processor of a different family. Intel Pentium 4 processor. Intel Pentium 4 processor that have the execution processor of 20 steps. It has higher clock speed. It performs fewer operation per clock. Pentium processor typically have the socket of 478 pin. So those processor of a Pentium 4 have a 478 pins inside it. Remember that the Pentium 4 processor also its speed was in megahertz, not in a gigahertz. I still remember, so while I was using a Pentium 4 computer, so its speed start from 733, because Pentium 3 stopped at 733 megahertz, but while Pentium 4 start, so from 733 onward megahertz processor, that was a Pentium 4 processor. AMD processors, AMD processor have the execution process of 10 step. You can see here the processes of 20 step in a Pentium 4, and AMD have 10 steps. Okay, so AMD processor typically have a socket of 462 pin, so they have less pin as compared to the Intel processor. They do not use megahertz to measure the speed, so their processing speed are not measured in a megahertz. They have their own unit to measure their speed. Comparison of Intel and AMD processor. So let's discuss here clock speed of Intel 1.7 to 3 gigahertz, and bus width is 32 to 64 bit. But same processor, if you see AMD comparison between Athlon processor, which was 1.4 to 203 2.33 gigahertz, as bus speed is 32 bit as well as 64 bit available. The important thing is the cache memory. Intel processor have a cache memory from 256 KB to the 1 MB. But while we talk about Athlon AMD processor, it is from 256 to 512 KB. Intel Pentium processor use CISC and RISC both architecture, but AMD processor use RIC architecture only. Here, this is the latest comparison between AMD Ryzen and Intel Core 9 specification. So if you see here, how many cores in Intel i9 processor, 7th generation, that is 18 cores are there, but AMD Ryzen 7 have 8 cores. So cores are a lot of difference between these two cores. If we talk about here cache memory, Intel Core i9 processor have 24.75 cache memory, which is a L3, but AMD have 16 MB cache memory. Okay, and if you see the price, so of course Intel processor are expensive as compared to the AMD processor, because they don't have that much performance, which they are saying that we are creating the processor which is going to be utilized as an Intel processor. So if you see here, the availability date is late 2017 and summer 2017.